Hi everyone, in this video we are going to talk about how we can use the energy level diagram to predict solubility. So in this case we are looking at the solubility of silver chloride. Alright, we want to see whether it is soluble in water. So typically when we talk about solubility we have four different equations. Alright, we need the delta H solution of the solid itself. We need lattice energy. Alright, we also need delta H hydration, which is uh, which is unique to the individual ion itself. Alright, so we have one for Ag plus and we have another one for Cl minus. So before we can draw the energy level diagram, let's first start by drawing the energy cycle. Okay, so how do I connect them together? We will connect everything that looks similar together. Alright, so I will start by copying down my delta H solution equation, which is AgCl. Alright, solid delta H solution breaks into Ag plus aqueous plus Cl minus aqueous. Okay, and the next step is for me to convert my Ag gas to Ag plus aqueous. So I get something like that, Ag plus gaseous plus aqueous. Alright, and I also have Cl minus gas over here, which is the third equation that we have seen. So we have completed this first three. We are going to connect our last lattice energy here. So notice that we have these two groups here, which is these two, and finally we can join them together using this arrow. So it's very important for us to take note of the direction of the arrow itself. Okay, so now what we can do is we can turn this into an energy level diagram. So how can we go about doing that? Okay, so I'm going to use some arbitrary values and I'm going to adjust the magnitude of the arrows itself. Okay, but let's see. Basically we want to draw a line, right? Our axis, our energy axis here. So we want our silver chloride solid to dissolve, okay, to give us to give us our Ag plus and Cl minus ions. But before we can do that, we don't know whether it is exothermic or endothermic, so let's fill in the rest of the information first. Right, so the first thing we know is that the lattice energy itself to form this solid will always be negative. Right, it's always exothermic because this is because bonds are formed. Okay, so it will always be exothermic. And likewise, when we are undergoing hydration, it will also be exothermic because it surrounds the ions. All right, water molecules surrounds the ions, and so bonds are also formed. So let's say this is the summation of the delta H hydration of both Ag plus and delta H hydration of Cl minus. Okay, I will omit this summation sign here, but basically this arrow talks about that, and I should be able to reach this state where I get AgCl aqueous. Okay, so the last line that I have is to connect these two things together. So basically if I extended this line, I will know that this will be my delta H solution. Okay, and we realize that this is actually an endothermic process, right, which shows that the energy released from hydration, right, is insufficient to overcome the ionic bonds within this compound itself. So that is why it's endothermic, and that is why AgCl is not is sparingly soluble. Okay, likewise, if we had another example, so for instance, if in another alternate universe, right, this summation value gives us something like this, where this is AgCl aqueous. Okay, and we get this arrow downwards, alright, this is exo. So what this means is that the energy released from hydrating the ions is more than sufficient to overcome the lattice energy within this ionic compound. So simply by looking at whether the final result is endo or exothermic, we will be able to tell if it is soluble or not. But of course, since we know that AgCl is sparingly soluble, then this should not be exo, this should be endothermic. So these values will be wrong. Alright, so this can be applied to a multitude of cases. There will also be other questions where you can use the energy level diagram, right? Depending on whether you have the same reactants or the same products, and you can use them to see which is, you can use that to see which reactant or product is more stable.